Hello, and welcome back to Airspace Link's AirHub Academy series of training videos. Today, we are going to discuss the HexGen Surface Engine. Before we start, just a little background. Accessing the HexGen and Surface routing features is a straightforward process. If you're a manager or have been assigned the manager role by your supervisor, you're good to go. As you can see in my account, I have the manager, operator, and director roles. With the manager role, I can easily utilize the HexGen Surface routing feature. To access the Surface routing feature, once I'm logged in, I need to click the Discover tab, and if you have the proper permissions, you will see the Surface routing feature here. Now, I'll go ahead and zoom out just a touch and click the Surface routing feature. For the purposes of this demonstration, I'm going to use the city of Detroit, Michigan. Before we start exploring the features of our surface routing, HexGen engine, let's understand its significance. Portal surface generation and routing features are designed to streamline drone mission planning. By integrating various data sources into a unified scored surface, it enables efficient risk assessment and identification of potential hazards in larger areas, thereby enhancing mission safety and effectiveness. By utilizing this data, our autoroute service calculates the most efficient point-to-point paths, significantly reducing planning time and basing missions on comprehensive data. Routes optimized through this service can be exported in KML format, ensuring compatibility with a range of third-party visualization, planning, and ground control tools for enhanced mission execution or analysis. Most importantly, the feature enhances flight safety by directing drones around a higher scored or riskier area or areas at predetermined altitudes, thereby minimizing the chances of accidents or airspace violations, giving you the confidence to plan and execute your missions with peace of mind. This combination of surface generation, routing, and export functionalities offers a comprehensive, efficient, and user-friendly solution for drone mission planning. Now, let's delve into our three options: surface generation, routing, and exports. Surface generation generates a custom surface based on the selected AirHub Insights data features and user-selected scores, making your mission planning experience as smooth as possible. The selected scores can be used to represent whatever profile the user intends, whether it be risk, suitability, obstacles, or other options. For routing, you can generate an optimized route based on the surface model defined by the user, what we just spoke about, the surface generation. Finally, exporting. Once you have created a route, you can export the route using specific tools to a KML file to be imported into other visualization, planning, or ground control software. Once again, you can export the route generated by the user at a specified above ground level altitude to a KML file to later be imported into other visualizations, planning, or ground control software. The Surface Generation Service enables users to consolidate numerous AirHub Insights data sources into a unified scored surface, which makes evaluating a large area for hazards or risks much more efficient and intuitive. The AirHub Autoroute service calculates the optimal point-to-point lateral route around high-scored areas in the user-defined surface at a user-specified above-ground level altitude. This surface generation, routing, and export feature streamlines drone mission planning by offering data-driven risk assessment, optimized routing, and seamless integration with third-party tools, ensuring safer and more efficient drone operation, such as efficient risk assessment. Surface generation consolidates various AirHub Insights data sources into a unified scored surface, simplifying the process of evaluating larger areas for potential hazards or risks. It also offers optimized routing. An autoroute service leverages the generated surfaces to calculate the most efficient point-to-point routes, significantly reducing the time spent planning drone missions while ensuring they are based on comprehensive data. Users can then export the optimized routes into a KML file format, ensuring seamless integration with various third-party visualization, planning, and ground control software for further mission execution or analysis. It also offers enhanced flight safety by routing drones around high-scored or potentially hazardous areas at specific altitudes. Operators can ensure safe flight paths, minimizing the risk of accidents or airspace violations. Finally, these all create a streamlined planning process. Combining surface generation with routing and export functionalities offers organizations an all-in-one solution, making drone mission planning more efficient, data-driven, and user-friendly. Let's say an organization manager or operator wants to evaluate an area they plan to conduct drone operations for hazards, risks, or other features that would impact their operation plan or route. The manager can generate a surface showing the location and severity of different features in their area, and generate different routes to simulate potential operations that minimize their exposure to hazards, risks, or other features. After the routes are generated, they can be exported into a KML file to load into Google Earth Pro or a ground control software to simulate an operation against their internal policies or procedures. Now, let's explore the HexGen Surface Engine. Just to reiterate, I'm already logged into Portal. I'm on the Discover tab, and I've clicked the Surface Routing feature. Again, I am in the geographic locale of Detroit, Michigan, and this is the Surface Routing Tool interface. If you're familiar with Portal, just like creating an operation or an advisory, you need to sketch an operating area or the geographic locale of the surface you want to evaluate. We have 3 levels of resolution: low detail, medium detail, and high detail. I'll explain these further in a moment. We also have our surface profiles. Airspace Link offers many different datasets, and the ability to create and save your own profiles and datasets will soon be available. If you would like to speak with an Airspace Link representative, we can also help you add your own datasets for your surface profiles. For the purposes of this demonstration, I'm going to accept our default template of data sources. As you can see, each of these data sources comes with a default score. Higher scores indicate areas you want to avoid, while lower scores indicate areas of less risk. Each of these scores is fully editable from high to low. To add some context, a score of 10 will indicate that you do not want to fly over that hazard. A score of 0 will indicate that you prefer to fly over that hazard or feature. If you want to ensure that you always fly over that feature, giving a score of -1 will ensure that that feature is optimal for your operation flight path. As we scroll down, we have the ability to create a route overlaid over the generated surface. But first, let's look at some of the features, starting with the surface resolution. As I stated before, we have a low detail, a medium detail, and a high detail of surface resolution. The detail indicates the hex size that will be displayed on your surface route. For low detail, the hexes will be larger. For medium detail, they will be smaller, and for high detail, they will be small and concentrated in a smaller area. This would be the selection to use when getting information about a small area. If you're looking for generalized information about an area, you would use the low detail. I will demonstrate this briefly here. I'm going to zoom into the Detroit area and draw a simple rectangle. Now that I have my rectangle drawn and my low detail selected, I will click Generate Surface. As you can see, I have very large hexes around the area that I want to operate in. The lighter the color of the hexes indicates a maximum level of risk, and the darker the color indicates a minimum level of risk based on my selections. If we are routing, our route will follow the darker colored hexes and avoid the lighter color hexes. I can also get more information about what's behind these hexes by simply clicking on them. If I click on the one here to the northwest, you can see the selected surface cell opens. The score is 10 of 10. The features are parks and schools. If I look over here, my schools are 10 and parks are 4. If I come down here with the darker colors, you can see I have a score of 4. Now, suppose I want more information about an area where I'm going to fly and want to see detailed information about it. For this instance, I will zoom in tighter and select an area here. So, you can see that I have obstacles, a power substation, and a helipad in addition to the medical center here. I'm going to leave my default surface selections and select high detail for my surface resolution. Now, when I create my area and click Generate Surface, you can see that I have many more hexes with a variety of colors. Again, I'm showing areas with the least amount of risk based on my criteria. If I click here on the green hex again, my selected surface cell displays a score of 8 and the feature is a hospital. And again, if you look at hospitals, I've rated them 8. So this is an area that I would want to avoid. As you can see, this is only a 4. This is a park, an area that I would most likely like to fly through. We will create a route to bring this all together so you can understand what these surface hazards mean. I have my default surfaces selected. Now, I want to find the best route for flying. In this case, we're envisioning a medical delivery use case. Maybe we're starting at a medical facility down here and delivering to this hospital helipad with a few stops along the way. I'm going to zoom out just a touch, and I'm going to put my planned altitude at 200 feet. Now, I'll sketch my path. As I stated, I want to start my route at this medical facility to the southeast and end up at the hospital indicated by the blue H. It's a very simple route. So I click Generate Route, and in just a few seconds, my optimized route has been generated. The dashed lines indicate the original route that I wanted to fly. The solid white line is the route that the HexGen surface engine has decided, again, based on my criteria and level of detail, is the best route for flying over the hazards I have indicated. If we start here, we can see that we're in an area that does not have any hazards, according to the criteria we have established. Coming through here, you can see that I do have to fly through some more hazardous areas, but again, the route sticks to the safest route. Finally, if I want to keep this route and export it for use in Google Earth or a ground control station software, I simply hit the down arrow here and start the download of the KML file. The download will automatically go to whatever file folder you selected. The exported data can be used in any of the above-mentioned software, such as Google Earth or other ground control software. I'm going to go ahead and clear my path, zoom out, and do one more in a separate area of Detroit. As you can see, I have a railroad running through here. In this instance, I want to fly mainly along the railroad and avoid other hazards. However, I do have some stops along the way, so I'm going to leave my details on high. As far as my railroad line scoring is concerned, I'm going to change this to a -1. This will ensure that I fly along the railroad lines as much as possible to get to my endpoint. So, this time, I'm going to create a polygon, starting here, crossing the railroad lines, and continuing my route. Now you can see the area that I want to fly over. All scored surfaces are the same except for the railroad lines, which I changed. I will leave my planned altitude at 200 feet, and again, I will sketch a path. I'm going to start here. To simulate stops on my route, I'm going to cross the railroad tracks, cross them again up here, and finally end in this area. Now, I'll generate my route. You can see my original route is this dashed line. However, since I indicated that I wanted to follow the railroad lines as much as possible, with stops along the way, my route starts here, immediately heads for the railroad line, comes down here, heads back for the railroad line, and again attempts to follow the railroad line as much as possible, to the end of my route. In addition, you can see that my route encompasses the least amount of risk possible through my flight path. A few areas where I might run into some issues are routing around a school here and around schools here. Other than that, we follow the railroad lines closely, and in this case, our flight displays a minimum amount of risk. Well, that about does it for surface routing. If you have any questions or concerns, or would like to have your own demonstration of the surface routing and surface HexGen engine features, please don't hesitate to contact us. Thanks for listening, and happy flying!